In this video we're going to be solving a linear equation, but one containing variables on both sides. Okay, so this is a little bit different from a two-step equation. So we're going to lay out a little bit more general way for solving equations that have variables on both sides, or just equations in general. So to be very, very formal about it, let's go ahead and put in some text. Solving equations with one variable. We'll kind of lay out the rules here. But essentially, step one, what we want to do is this. We want to simplify both sides. Now, what I'm talking about when I talk about simplify is distribution, okay, or simple operations that can be carried out. Okay, we want to go ahead and do those things first. But the next thing we want to do is this. Get all unknowns that we're solving for. We're typically solving for unknowns, but get all unknowns on the same side. Once we get all the unknowns on the same side, what we're going to do is next we are going to eliminate anything that is not the thing that we're solving for. Essentially, use inverse properties. And when we talk about using inverse properties, we're talking about using like addition to undo subtraction, or division to undo multiplication. And last but not least, we're going to check our solution. Okay, so we want to make sure that we get these steps written down here, because these are really important to follow in every equation that we solve. So let's go ahead and carry these out. It says, often we'll have variables on both sides of the equation. It says, recall that if our goal is to isolate the variable, then we can't have variables on both sides because we want to get it by itself. So we're going to gather all the variables on one side of this equation. So we're going to solve for this and check for the solution of n and make sure it's right. So you notice here that step one says simplify both sides. I don't have any distribution to do on the left or the right, and I don't have any simple operations that I can actually combine like terms or anything. Okay, so the next thing we want to do is this. Get all the unknowns on the same side. We have to pick a side to clear of n's. Okay, we want to get all the n's on one side. So I notice here that I have 7 n's on the right that are positive and 5 n's on the left. If I wanted to clear a side, say the 5n side, what I would have to do is I would have to undo the 5n. I would have to subtract 5n from both sides. Okay, let's see if I can move this to the front here so I can write on this. So we'll subtract 5n from both sides. Now we could have subtracted 7n from both sides, and what that would have done is it would have cleared the right side of 7n. But you notice here that 7 minus 5 is going to leave us positive 2n's on the right, with this negative 9 being carried down. And on the left side, we had our 5n's cancel out. We're left with 11. Okay, so it is typically good practice to, eliminate the variables on one side to the other side that leaves behind a positive coefficient. Okay, if we had done it the other way, we would have just had a negative coefficient in front of our n. So now that we have this on that side, we say, number 3, eliminate anything that is not the thing we're solving for. So since we want to solve for this n right now, we need to eliminate the 2, we need to eliminate the 9, the constant here. So just like in the last video, this is a two-step equation. It's always better to undo addition and subtraction first. So we're going to add 9 to both sides. On the right side, we're left with just 2 n's. On the left side, we're left with 20 constants. And then last but not least, we need to get rid of this 2. Now I notice that I'm taking 2 times n, so I'm going to undo that by doing the opposite of multiply by 2. We're going to divide by 2. And so those 2's cancel out. We're left with just n on the right. This is 1 times n, or n. We're left with 10 on the left. So now, since we think this is our solution to the equation, oops, sometimes we have solutions, but in this case we have a solution, we're going to check it. This is our last step in our process here. So what we mean is this. We're going to take the original statement, and everywhere we see an n, what we're going to do is we're going to take that out. We're going to put in what we think we found for n. And in this case, we think that n equals a 10. So we're going to put that in both of those blanks. We say that we get 50 plus 11 equals 70 minus 9. In this case, 50 plus 11 is 61, and 70 minus 9 is 61. So this must be a solution, and the reason why is because that this is a true or valid statement. Okay, cheers.